Okay, hello students, welcome to you all. This is topic indefinite integration, lecture number 17, and today we are starting with a new subtopic, that is integration by parts. Very interesting subtopic, integration by parts. When we will learn this, we'll be able to solve many very interesting problems. So let's begin with it. So the statement of the theorem, integration by parts, the statement of the theorem, quite interesting name it is. You can just follow the name integration by parts. Okay, so parts we all understand. Parts is we make parts of some given thing. So what are we going to do here? In order to integrate a given function, we are going to make parts of that. Not several, actually two parts only we are going to make. So, but still two parts we are going to make. A given function, we will make two parts of that and we will integrate. That is why the name is integration by parts. So let's begin with it. The statement of the theorem says if u and v are two integrable functions of x. Now see here, I have written here integrable functions of x. What are u and v? U and v are integrable functions of x. It means these two functions can be integrated. Integrable functions of x means it can be integrated. So then there is a question that are there some functions which are not integrable functions? Definitely yes. See, in order to have a function which is integrable, the function needs to satisfy certain conditions. So if the functions are satisfying those conditions with which it will be an integrable function, then only it is integrable. Otherwise, it is not integrable. So here u and v are satisfying all those conditions which are required for them to be integrable. And that's why we call them as integrable functions of x. They can be integrated with respect to x. So if when u and v are integrable functions of x, then integral uv dx, then integral uv dx. Now see, this is the function which we want to integrate. We want to integrate the product of u and v. Okay, so this is my integrand. What is integrand? The integrand is u into v dx. I want to integrate the product of uv. Okay, so the product of uv integration is the formula this way. When you are integrating a function which is product of two functions, when you are integrating a function which is product of two functions, what you do, how you integrate it like this. Now this right hand side which I have written, it is quite interesting. You will notice that though you are integrating the product of u and v, even though you are integrating the product of u and v, on the right side you notice that you have only integrated v. See, it is integration v dx, integration v dx. You will notice that u has not been integrated even once. There is not even once that u has been integrated. And this is the beauty of this theorem. This is the surprise of this theorem, beauty of this theorem. What is it? You have to integrate the product u into v, but that you can achieve without integrating u. You can achieve the product uv being integrated without integrating u. How fantastic it is. That is why we call it integration by parts. We are integrating only the part u into v. We are only integrating one of the part. So what does theorem say? The theorem says that you integrate v to two times. When the first time when you integrated first time, you multiply u, and when you integrated for the second time, you multiply derivative of u. First time when you integrated v, when you integrated first time, you multiplied u. When you integrated second time, you multiplied derivative of u with respect to x. And this second time what you have, you integrated this once again with respect to x and subtract it. Okay, so what I will do for you students, let me write this once again for you all. And then there are a few more points. First you learn the formula, and then there are a few more points to be covered which I will cover with you. So u into v dx, what is u into v dx? It is equal to, see, you will have to integrate v two times, integral v dx and integral v dx. Okay, two times. First time when you integrate, you multiply u is multiplied. Second time when you integrate v, you multiply d by dx of u, and then you put this in a bracket and integrate this whole thing once again and subtract it. It is done. See, it is done. I know there are few more questions which your mind must be wondering about. Don't worry about them. All those doubts I will be clearing. Right now, you just focus on the formula. The formula has to be understood. Once again, I write here. Integral uv dx is equal to integral v dx first time, so multiply u. Integral v dx second time, so multiply derivative of u and integrate this whole thing once again and subtract. Okay, what I will do is let me integrate this time from right to left without any break. See here, so integral uv dx is u. Now I will write u integral v dx, the first one, minus big integral, and the bracket is d by dx of u integral v dx and the whole dx. How simple formula it is. How simple it is. Okay, so first you try to learn the formula, and then I will teach you some more tricks here. So I hope you all must have followed the formula which I wrote here. Okay, now one thing you should all follow here, students, that when I'm writing product of u into v, then I call this u as first factor and v is the second factor. Okay, so this is first factor and this is second factor. Okay, or you can call this as prefactor. U is prefactor, v is post factor. Now what you follow is, when I'm writing integral uv dx and I'm applying integration by parts, it is only this post factor which is being integrated. Only the post factor being integrated. The prefactor is nowhere integrated. Now the question here arises is, what if I integrate v into u dx? That is, suppose instead of writing uv dx, what if I write v into u dx and I integrate? Let's see here. Suppose I write, okay, please follow this here. Suppose I write integration of v into u dx. Now see here, I have changed the order. Order is changed. I have written v as the first factor and u as second factor, okay, which is reverse of what I had done here. So what will happen here? So here, remember, you will integrate u two times. You will integrate u two times. This is according to the law. According to the statement, you will integrate u two times. So let us integrate u two times. So u dx, first time when you integrated, you will multiply v. Then again u dx, second time when you integrate u, you will multiply derivative of v. And then this thing you will integrate once again and subtract. You will integrate once again and subtract. Okay, let's do this once more. So here we have uv dx, and now I write integration of v into u dx. What it will be? See, it will be v integral u dx. I'm going to integrate u only. This time only u will be integrated. As earlier, only v was integrated. Always the second factor is integrated, not the first one. So here we will have integration of v into u dx as v integral u dx minus big integral and then d by dx of v integral u dx, the bracket close, and dx. See here, this is. So after this, I know one more question you all must have got, and that question would be that uv is same as V into U. Yes, that's true. U into V and V into U are same. For example, if I have sin x into log x, sin x into log x, or I have log x into sin x, they will always be equal in all respect. They will have the same domain, they will have the same range, they will have always the same value for a given x. So sin x into log x is always equal to log x into sin x. So if this is true, why am I getting different integration when I'm integrating uv and vu? Mind the students, this is very interesting. U into v dx, I'm getting this. V into u dx, I'm getting this. Whereas uv and vu, they are equal. So if these two are equal, why not these two, or these two look equal? They look very much different. See, the reason is, it is found that integral uv dx and vu dx, you can integrate the way you want, because integral uv dx is same as integral v into u dx. So you can integrate whichever you want. You can integrate either of them, whichever you want. But the fact is, when you will integrate, you will realize that one of these two gets you the final answer, that is, it reaches to the final answer, and the other does not reach to the final answer. It doesn't get you the final answer. That is why we have to choose one of them and proceed. U into v is same as v into u. Sin x into log x is same as log x into sin x. But when you will integrate sin x into log x dx, sin x into log x dx, or you will integrate log x into sin x dx, you will find that one of these two gets you the final answer and the other does not get you the final answer. And that is why we have to decide which one we should select. Though they are same, but the selection has to be properly done, which I'm going to teach you in a short while. So here from this discussion, what we followed is that selection of the order in which we select the functions are important. The order in which we select these functions is very important. When I'm asked to integrate, say, e raised to x into sin x dx. So here I notice that one of the function is u. I noticed I have product of two functions. So which one I should write as first factor and which one as the second factor? This is very important. This is very important. I should take this as the second factor, because remember, whichever is second factor, that will only be integrated. So if I write e raised to x into sin x dx, and I begin in that case, the right hand side will look like e raised to x integration of sin x dx minus big integral d by dx of e raised to x integral sin x dx and the whole dx. If I choose to write this way. On the other hand, students, if I choose to write sin x into e raised to x dx, see, I change the order. Now I'm writing sin x as the first factor, e raised to x as the second factor. If I choose to write this way, then the integration will be sin x integral e raised to x dx minus big integral d by dx of sin x integral e raised to x dx and whole dx once again. So you can understand the right hand side, the left hand side of these two integrals are same. They are same. They are equal, but the right hand side look very much different. It has to be understood that one of these will get you the final answer and the other will not get you. The other will get you into a loop. It will become endless. You will keep on integrating, it will never end. So the question here is, how do I know which one of these is correct? I mean, which one of these is proper? Which one of these I should go ahead with? For this, there is a priority code which we are going to see. So here I write priority code for deciding the order of functions in integration by parts. So what is that priority code? I will write it. The priority code is L I A T E. Liet. The priority code is Liet. Now this E stands for exponential functions. Exponential functions have the least priority. They are at the last. You can check. The first one is logarithmic, then inverse trigonometric, then algebraic, then trigonometric, and finally exponential functions. So exponential functions have least priority, then trigonometric functions. After trigonometric, then before trigonometric function, we have algebraic functions. Before algebraic functions, we have inverse trigonometric functions. And before inverse trigonometric functions, we have logarithmic functions. So you have to see from here. Don't follow this order, please. This is not the order. The order is not this way. The order is this way. This is the order. Okay. So you don't have to follow this here only I have written the name. The actual order you will follow from here. See, this is first, second, third, fourth, and fifth. Which has the highest priority? The logarithmic function has always highest priority, then inverse, then algebraic, then trigonometric, and then exponential. Okay, so following this, see here, I will write Liet, L-I-A-T-E, Liet. I will write here Liet, and now check. What I notice here is e raised to x is exponential function. This is exponential function e, and sin x is trigonometric function t. So here the order you see is et, but you can check here, it should be te. Trigonometric should be ahead of e. So this order is not proper. It is not proper. You will not integrate it this way. This order is proper. I hope you all must have understood. Don't worry, students. This is going to be very simple. I will solve many problems for you, and each and every problem as you go ahead, you will find the things become easier and easier. Let's start with few problems. We will begin with few very simple questions for understanding the formula which we just wrote for integration by parts. So to begin with, so here I have 1, 1. Okay, the book which I am following, it is 1, 1. So I'm writing for my reference. You have to only understand the questions. You have got no concern with the numbers. For you, every question is a new question. So here we have to integrate x square multiplied to log x dx. You have to multiply x square, you have to integrate x square into log x dx. So how do we begin? Always we write let I equals to x square into log x dx. So students, what you notice that you got product of two functions. One function is x square, which is an algebraic function, and the other function is a trigonometric, or the other function is a logarithmic function. I'm sorry, it's a logarithmic function. So here you write a, this is algebraic, so it is a, and here you write L. So the order that you notice is AL, but the priority code you have is LIAT, LIATE, Liat, Liat. The best way to remember this is what? Liat. Okay, you can write in Hindi as Liat, Liat. So LIATE. So I understand that it is L which should be before A. L should be before A. L is before A, but here A is before L. So this order is not proper. I should not follow this order. And what should I do, students? Very simple. I should change the order. So x square into log x is same as log x into x square. And then I will write integrating by parts. Now the order is proper. I will write here integrating by parts. Integrating by parts. So I get here I, as you know, students, when you write the order, always the second function, the second factor is integrated. The first one is never integrated. First one is once multiplied as it is, and the next it is multiplied with its derivative. So here I write log x integration of x square dx minus big integral d by dx of log x integral x square dx and the whole dx. This is how it is, integration by parts. So here you have log x into integration of x square dx is x cube upon 3 minus d by dx of log x is 1 upon x, and integration of x square dx is x cube upon 3, and integration of x square is x cube upon 3, the bracket close, and dx. Bracket close and dx. The next you write here is therefore I equals to log x into x cube upon 3 minus 1 upon 3. 1 upon 3 is constant. See here you got 3 in the denominator, so 1 upon 3 is constant, and this is 1 upon x and x cube. So you have x square dx, integration of x square dx. This is x cube, this is x cube, here you have x, so 1x cancel, you get x square. So you get here integral x square dx. Next step is I equals to log x into x cube upon 3 minus 1 upon 3 and integration of x square dx. What one has to follow here is that this part of the formula, there are two integrals. Remember, there are two integrals in this part of the formula. So first you integrate the inner one, and after you have integrated, whatever you are getting, that is once again integrated. Remember, that is once again integrated. So this integration here is the second time that you are integrating. 1 upon 3, and integration of x square is once again x cube upon 3. Okay. Now what you notice that you have no integral sign here. Do we see any integral sign here now? Do you see any integral sign here now? No. There are no integral signs here. So once you notice that you are left with no integral signs, you will add the constant of integration. You add the constant of integration only when you see no integral signs. So here we add c. So I equals to, you have log x into x cube upon 3 minus x cube upon 9 plus c. This is the final answer. You all can once again see the whole solution and practice it on your own. Practicing is very important, students. You have to practice these. So here we have second question for practice, x square multiplied to sine 3x dx. So I have product of two functions to be integrated. When I have product of two functions to be integrated, the first thing I will think of is integration by parts. Okay, x square into sine 3x dx. Nothing helps me but integration by parts. So here I will first check the order. What is x square? X square is algebraic. What is first step, students? We check the order. We check the first step is we check the order. So order of the function, x square is algebraic, and sine 3x is a trigonometric function. Sine 3x is trigonometric function. So here we have at, and write the order that we know. It is LIA TE, Liet. So here we have order AT, and here also it is AT. So the given order is correct. So I can begin with the formula. I will write integrating by parts. Integrating by parts. And as we all know, students, always the second factor is integrated. The first one is not. So I equals to x square integral sine 3x dx minus x square integration of sine 3x dx minus big integral d by dx of x square into integral sine 3x dx, and this whole thing is integrated once again. So you have therefore I equals to x square integration of sine 3x is minus cos 3x divided by 3 minus d by dx of x square is 2x, and here you have integral sine 3x, which is minus cos 3x divided by 3, and once again dx. Next step is I equals to minus x square into cos 3x divide by 3. This negative will come out, it will become positive. 2 upon 3 is a constant. 2 upon 3 is a constant multiplied to the whole function. So 2 upon 3 I'll write out. And here I have integration of x into cos 3x dx. Okay. So what I notice here is that after integrating by parts once, after applying integration by parts once for this, once again I'm getting integration by parts. See, here we are getting integration by parts once again. We will have to apply the formula once again. Why? Because see, we have to integrate cos x into cos 3x, the product of two functions, cos x into cos 3x. So here the next step is, order is correct, students, so you need not worry about the order. Order is correct, x into cos 3x. algebraic and then trigonometric. Order is correct. Order is same as this, which was correct. So here I write I equals to minus x square into cos 3x divided by 3 plus 2 upon 3, and then I make a bracket because I know. Why is this bracket? Because I know that this constant which is outside, it will be multiplied to all the terms which I am going to get. I know when I apply integration by parts, I end up getting several terms. So this 2 by 3 will be for each one of them. So I put that bracket. So here integral x into cos 3x, it will be x integral cos 3x dx minus big integral d by dx of x integral cos 3x dx, and then bracket is closed once again dx, and this final bracket is closed. So what do I have here? So the next step is I equals to minus x square into cos 3x divided by 3 plus 2 divided by 3, inside the bracket you have x integral cos 3x. This is sine 3x upon 3, sine 3x upon 3 minus, now d by dx of x is 1, and integral cos 3x dx is sine 3x divided by 3, bracket is closed, and dx once again, the outer bracket closed. So you got negative of x square into cos 3x upon 3 and plus 2 upon 3 x into sine 3x upon 3 minus 1 upon 3 is out, integral sine 3x dx, and the bracket closed. Now this 2 by 3 multiplies inside. So I equals to negative x square cos 3x upon 3 plus 2 upon 9, 2 upon 9 x into sine 3x minus 2 upon 9. It multiplies both the terms. So minus 2 upon 9, and here I have integral sine 3x dx, that is minus cos 3x divided by 3. And now I write finally C when there are no integrals left. So I equals to negative of x square cos 3x upon 3 plus 2 upon 9 x into sine 3x plus 2 upon 27 cos 3x plus c. This is final answer. You can check the solution once again. Watch it once again and try to solve this on your own. You can read the solution once and then practice it once again on your own without seeing it. Yes, so now we have three questions here which look similar. They are not exactly similar, but then they are looking similar. So few things in the beginning of the steps will definitely be same, and at the later stage you will find that there are different ways of integrating this. But then what I will do is from amongst these three, I shall be doing fifth one for you, and these two problem I leave for you as a practice problem. So you all must try this. In case if you do not get the solution, you search for the solution, and if you are not satisfied with the solution that you want, that you got, you want me to solve this, you can leave your comment in the comment section. I will definitely solve this for you. So here I begin with fifth question. So fifth is let I equals to integral x cube into tan inverse x dx. Once again, what I notice, students, I notice that I have got product of two functions here, x square, x cube and tan inverse x. So here to integrate this product of functions, I will use the help of, I will take the help of integration by parts. Okay. So in integration by parts, the first thing I need to check is the order in which they are multiplied. So here this is algebraic and this is inverse trigonometric function AI. But the priority code that we follow, it is LIATE, liet, LIATE, liet. Okay. So according to this priority code, inverse trigonometric function is before algebraic function. Inverse then algebraic. Here it is not proper as per the priority code. It is AI. So what I should do, I should first change the order before I go for applying the integration by parts. So I write here tan inverse x into x cube dx. And now I apply integration by parts. I write here integrating by parts. Integrating by parts. So what do I get? I get I equals to tan inverse x integration of x cube dx, tan inverse x integration of x cube dx minus big integral d by dx of tan inverse x integration of x cube dx and the whole dx. So the next step here we will get is I equals to tan inverse x integration of x cube is x raised to 4 upon 4 minus big integral d by dx of tan inverse x is 1 upon 1 plus x square. Integration of x cube is x raised to 4 upon 4 dx. X raised to 4 upon 4 dx. So here I have therefore I equals to tan inverse x multiplied to x raised to 4 upon 4 minus 1 upon 4 out, and here you have x raised to 4 upon 1 plus x square dx. X raised to 4 upon 1 plus x square dx. Now at this stage, when you reach for the second integral, here you have to be a bit careful about integration. Like you should know what type it is. If you know the type, you'll be able to integrate. So this is polynomial upon polynomial, and the degree of the polynomial in numerator is greater than the denominator. So you can go for long division method, which I have already taught you. You can actually divide, like you can do this x square. I'm sorry, not x square. Here numerator is x raised to 4. So x raised to 4 divided by x square plus 1. You can actually divide this because the degree of the polynomial in numerator, degree of numerator polynomial is greater than degree of denominator polynomial. So whenever we have the degree of numerator greater than degree of denominator polynomial or equal, then we go for long division method. This is what you can do, and then you can integrate this. Okay, this is one way you can do it. But here I see this method you can definitely go for. But I see here something different, because of which I can go for the other method. See here, what I do is I go by some manipulations. Okay, so here what I do is I have x raised to 4. I write minus 1 plus 1. I subtract 1 and add 1. Now, why do I do that? You will know. See here, I write then tan inverse of x into x raised to 4 upon 4 minus 1 upon 4. And now this x raised to 4, I can write x square the whole square, minus 1 square plus 1, divide by 1 plus x square. Okay, so what I did, I had x raised to 4, I subtracted 1, added 1, then x raised to 4, I wrote x square the whole square minus 1 square plus 1 and dx. Okay, this 1, I wrote 1 square. So the next step I write is I split the denominator. And how do I do it? See, I write this upon 1 plus x square and 1 upon 1 plus x square. I split the denominator. So when I split it, see how do I get? I get I equals to tan inverse of x into x raised to 4 upon 4 minus 1 upon 4, and now I split the denominator. So I have x square square minus 1 square upon 1 plus x square plus 1 upon 1 plus x square. So right now what's going on? Transformation is going on, the transformation. So we have I equals to tan inverse of x into x raised to 4 upon 4 minus 1 upon 4, and see here what we have. We have here, a square. See, this is a, I can consider it to be a. So a square minus b square. I have here a square minus b square. So what do I get here? I get here a minus b into a plus b. So I get here x square minus 1 into x square plus 1. X square minus 1 into x square plus 1 upon 1 plus x square plus 1 upon 1 plus x square and dx. Okay, what happens next, students? See, x square plus 1 cancels. X square minus 1, x square plus 1, and then x square plus 1 cancels. So the next step I get is I equals to, I get here I equals to tan inverse x into x raised to 4 by 4, tan inverse x into x raised to 4 upon 4 minus 1 upon 4 minus 1 upon 4 and integral x square minus 1 plus 1 upon 1 plus x square. X square minus 1 plus 1 upon 1 plus x square dx. So here I have therefore I equals to tan inverse of x into x raised to 4 upon 4, x raised to 4 upon 4 minus 1 upon 4, and now I write separate integral for this. So here I put a big bracket and then write integration x square dx minus integration 1 dx plus integration 1 upon 1 plus x square dx. Okay, and the bracket is closed. So here I get I equals to tan inverse of x into x raised to 4 upon 4 minus 1 upon 4, and integration of x square is x cube upon 3 minus integration of 1 is x, integration 1 dx is x, plus integration 1 upon 1 plus x square is tan inverse of x plus c. This is final answer. This is final answer. You can multiply this minus 1 by 4 and you can check. So students, here we have the whole solution. You should practice this problem once again. You can watch this whole solution once again, then pause the video, try to solve this on your own. If you get stuck somewhere, once again see the video. And as I solved for x cube into tan inverse x, you should try solving x square into tan inverse x and x into tan inverse x. Now the difference that you will note is here, when everything will go very smoothly till this, but then here when you will come, you will find a change in this integral. You will find a challenge here. You will see a challenge here. Okay, so you need to face that challenge, and you will have to, as I manipulated here, you will also have to do certain kind of manipulation, and the transformation is very much required. The transformation is required in order to integrate the function. Okay, and same for x into tan inverse x. Practice this. If you have any doubt, you can put it into comment section. I shall revert back to you. We will take some more problems on integration by parts in lecture number 18. This section will continue in the next lecture as well. Thank you for now. Thank you.